Greetings, welcome to this video. Let's continue with our series of non-linear inequalities. Only that in this case we'll be looking at rational inequalities. So let's get started, shall we? So question is, a typical question will be solve and say sketch on a number line. Alright, so before solving, always look at what you are given. Since we are talking about inequality, make sure that one of the sides of the inequality sign should have a zero. Normally that side is the left hand side or the right hand side, depending on how you are looking at it. If you are facing the screen right now, this would be your left hand, pardon me, this will be your right hand side, and this will be your left hand side. However, if you want to take a mirror version of that, it's you looking at yourself, then this becomes your right hand side and that becomes the left hand side. But that's okay. If that doesn't make sense, it will make sense eventually later on. Probably I should look at that. Alright. If you didn't get that, what I'm trying to say is that make sure one side of the inequality has a zero sign. So write your inequality in standard form. So we need a zero this side. So move everything on one side. That's the first thing you do. Always group all the expressions and constants on one side so that you can have 0 on the other side of the equal sign. In this case, we'll have 2x minus 7 over x minus 5. So that 3 crosses that inequality sign, it becomes minus 3 less than equals to 0. Okay, so once we have this, we can write this whole thing as a single fraction. How do we do that? Well, this is how we do it. This is one fraction, and this is another term. You can write it as a fraction also. 3 over 1 is the same thing as 3 over 1. So once we have that, we can then now look for the lowest common multiple of x minus 5 and 1, which is normally multiplied by two denominators, x minus 5 multiplied by 1, x minus 5 multiplied by 1. Okay, in this case, okay, x minus 5 multiplied by 1. So once you're done with the denominators, now it's over to the numerators. Look at the numerator of the first term, or first fraction. Numerator is 2x minus 7. You write it as it is, 2x minus 7. And then you look at the denominator. Look at the denominator and say how many times does the denominator, how many times is the denominator divisible by the new denominators, which is 1 times 5. So let's do that. X minus 5 times 1 divided by x minus 5. That one and that one cancels each other out. That leaves us with 1. So we multiply this one by 1. So if you are very observant, what you can already conclude from this is that if the denominator is a product, if the new denominator is a product of the previous, of the denominator of the individual fraction, then you can just multiply the numerator by the denominators of different fractions. This is what that means. Multiplied by 1, carry minus 3 as it is. Minus 3 we just multiplied by the denominator that doesn't belong to it, x minus 5. That's always what you do when you have a product of denominators. Okay, all these should be less than or equals to 0. So 2x minus 7 multiplied by 1 minus 3x minus 5, everything all over x minus 5 multiplied by 1 should be less than or equals to 0. Okay, so now let's work it out. Two x minus 1 remains as 2x minus 7 remains as 2x minus 7, because it's just multiplying by 1. Minus 3x, minus 3 multiplies by all the terms inside the bracket. It becomes minus 3x, minus and minus becomes positive. 5 times 3, that is 15, all over x minus 5. Less than equals to, okay, less than equals to 0. Now we collect like terms, minus 7 and positive 15, and 2x and minus 3x, that is minus 3x plus 2x plus 15 minus 7 divided by x minus 5 should be less than equals to 0. Okay, minus 3 plus 2, or minus 3x plus 2x, that gives us how much? Minus x, and plus 15 minus 7. So 15 minus 7, what does that give us? That gives us plus 8. Everything over x minus 5 should be less than equals to 0. Okay. Now at this rate, the reason why, okay, at this rate, we have now a single fraction, which was our goal. So having a single fraction here, we need to find out the values where this fraction is undefined and the zeros. So normally when it's undefined, it's when the denominator, this, is equals to 0. When you have a 0 here, when you have a 0 down in the denominator, this will normally become undefined. For example, let's say x minus 5 was equals to 0, and then x is equals to 5. So if x is equals to 5, let's say x is equals to 5, this will make this undefined. Let me show you. So minus 5 plus 8, wherever you see x, you replace it with 5. 5 minus 5 should be less than equals to 0. Then we have minus 5 plus 8. That leaves us with, let me take out the minus, leaves us with positive 3. because it's 5, 6, 7, 8. Positive 3 over 0 goes to less than equals to 0. 3 divided by 0, that's undefined. Undefined. Therefore, whenever you have such a case, whenever you divide by 0, you'll always have such a case. You'll have an undefined or an error on your calculator. So Alright, so we get the values that make the equation, the expression, and the equation undefined, and we also get the zeros for the numerator. In this case, this is the 0 for the denominator, then we find the 0 for the numerator. Minus x plus 8 equals to 0, so minus x is equals to minus 8, x is equals to 8. So the zeros here are 5 and 8. Denominators zeros, 5 and 8. What am I saying? Denominator 0 is 5 and the numerator 0 is 8. Cool. So now let's write them in ascending order. 5 and 8. And I will sketch them on a number line. Just heads up on the number line. On the number line, we do not want to include the value that makes the expression undefined. No, because it will not meet the condition. The condition states that this fraction, whatever expression on this side, this fraction expression we have on this side, must be equals to 0 or less than 0. Okay, cool. So we have 5 and then we have 8. So this divides the number line into how many regions? 1, 2, 3 regions. Positive infinity, negative infinity. This region is from minus infinity all the way to positive 5. This region is from 5 to 8. That region is from 8 to positive infinity. Question is, are the conditions met in either of these regions? The condition is minus x plus 8 over x minus 5 must be less than or equals to 0. There you have it. So let's pick random numbers from each of these regions and see if they meet these conditions. Okay, 5, we can pick a negative number if you want to. You can pick positive, minus 5, all the numbers until all the way to infinity. You can pick any. I would take 0. I'll take 0. Take 0. In this region, I would take 6. In that region, I would take 9. So, let's see where that takes us, shall we? Okay, x is equals to 0, what happens? Minus 0 plus 8 divided by 0 minus 5 less than equals to 0. Right here we have 8 over minus 5 It should be less than equals to 0 because it's a negative. So the condition is met in this region. We have minus 8 over 5, which is less than 0. If you want to see what that is in decimal form, you can just solve that further on a calculator. Or we can also do it here. So like, how many times is 5? How many times is 5 divisible by 8? That is 1, remainder 3. So remainder 3. How many times does 5 go into 3? Well, it cannot. So 0. 30 divided by 5, that is 6. So minus 1.6 is less than 0. Cool. Okay. Let's look at, is the condition met in this region? Definitely. Definitely. Condition is met in this region. 100%. Cool. Now we look at the second region. We say x is equals to 6. If x is equals to 6, then we'll have minus 6 plus 8 divided by 6 minus 5 should be less than or equals to 0. Minus 6 plus 8, that gives us 2. 6 minus 5, that is 1. And 2 is less than or equals to 0. That's not true. 2 is not equals to 0, neither is it less than 0. So, condition is not met in this region. What about the third region? Third region, we have x is equals to 9. We picked 9 as our x. So let's see. Minus 9 plus 8 divided by 9 minus 5 should be less than or equals to 0. Minus 9 plus 8, that is minus 1. 9 minus 5, that is 4. Is negative 1 over 4 less than 0? So that's a quarter. Is a quarter less than 0? Well, it's negative, so definitely it is less than 0 in this case. A negative quarter is less than 0. Let's write it as a in a decimal form. Minus 1 divided by 4 cannot, therefore plus 0, the point. Put a 0 there. When times does 4 go into 10? Goes in there 2 times. But it leaves a remainder. Remainder, that's 2. So a remainder is 2. 2. When times does 4 go into 2? Well, cannot, so put a 0, it's already there. Comma, 2 is already there. Then plus a 0 there. How many times does 4 go into 20? 5 times. So negative 0.25 is less than equals to 0. It is less than 0, not equals to 0. Therefore it meets the condition. Condition is met. One of the condition is met in this region. So now to plot or to sketch it. In this case, we found out that the conditions are met from minus infinity to positive 5. The conditions are met. But one thing we do know is that 5 is the 0 of the denominator. Therefore, 5 should not be included in this set, in the set of solutions. So we'll write it like that. Solution is all the sets of values from 5, excluding 5 all the way to infinity will give you the correct answer. What about in this case? Well, in this case, since 8 is the 0 of the numerator, this 8 is included. Zeros of the numerators are included, so we'll have a filled in hole. That 8 is included in the solution. And all the sets of values from 8, including 8 all the way to infinity, will give you a correct answer. So that's one way to draw it. And the domain will look like this, or the sets of values from minus infinity to 5. Well, 5 is not included. Union 8 is included, so we'll place a square bracket 8 all the way to positive infinity, then round, close it off, closing it off. Okay, cool. Now this is one way to sketch it. I want to show you another way to sketch the graph. Another way to sketch it. 5 at 5 gives you an undefined value, so 5 is not included. So we'll sketch it like that. All the values excluding 5 will give you the correct answer. Because 8 is included, it's the 0 of the numerator. We'll sketch it like that. This is the domain, the following. This is the following domain. Alright. Cool. That's how you solve the first one. Now let's look at the second one, shall we? As usual, solve and sketch. Okay, group all the like terms on one side of the inequality sign. Well, group all the terms, not the like terms. X minus 2, that's the first step. X minus 3. Okay, if 3 crosses the sign, it becomes positive. Then right there we have a 0. That's exactly what we want. Over 3, write this as a single fraction. So find a common denominator, lowest common denominator. Just multiply 1 and x minus 3. 1 multiplied by x minus 3. That gives us our lowest common denominator. Write down the numerators as it is. Multiply by, by the denominator of the other fraction. So multiply by 1 plus 3. Write 3 as it is. Multiply it by that denominator, not its own denominator, x minus you do it. That's the pattern. X minus 2 multiplied by 1 remains x minus 2. So 3 multiplied by x, that is 3x. 3 multiplied by minus 3, that is minus 9. Divided by x minus 3. All these should be greater than 0. In this case, you look at the numerator and collect all the like terms. X and 3x are the same, minus 2 and minus 2 are like terms. So x plus 3x, that gives us 4x. Minus 2 minus 9, or minus 10 minus 11 gives us minus 11 over x minus 3 should be greater than or equals to 0. There we go. We have it as a single fraction now. We've combined the two fractions. Now we just have one fraction. So now with this single fraction, we can find the zeros of the numerator and the zeros of the denominators. Okay. Normally the zero of the denominator makes the expression undefined, gives you an undefined solution. So x minus 3 equals to 0. That gives us x is equals to positive 3. So this is the zero of the denominator, which is not included in the set of values when we sketch. You'll see what that means. You've already seen it, but I'll show you again. And then we get the 0 for the numerator. 4x is equals to 11, therefore x is equals to 11 over 4. What is 11 over 4? 11 over 4 is the same thing as, when times does 4 go into 11, 2 times, and leaves a remainder. What remainder is that? 4 goes into 8 2 times. So, and that leaves 3 as remainder. So 3. Question is how many times does 4 go into 3? Cannot, 0. So 30 divided by 4. 4 goes into 24. 6 times. 6 times plus 4, that is 7. 7 times. So 24, 28, 7 times. So 2.7 remainder 2. 4 and 20, that is 5 times. So 2.75. 2.75. Okay. So 11 over 4 is the same thing as 2.75. Cool, let's just confirm it, double check that. X is equals to, alright, okay. 11, 4 goes in there, 2 times, remainder 3 over 4. Yeah, so that's the same thing as 2.75. No doubt, excellent, nice, good stuff. Okay, let's continue. So we have our roots, or we have our zeros. We write them in descending order. We have x is equals to 2.75 and x is equals to 3. 0 of the numerator and 0 of the denominator. Now we sketch our number line minus infinity all the way to positive infinity. We have 2.75 and 3. So regions how many? 2 regions. We have 3 regions, sorry. We have one from minus infinity all the way to 2.75 And then we have one from 2.75 all the way to 3. Then we have another region, which is the third region, from 3 all the way to positive infinity. Now let's pick some random values in there. I would say 2.75. I'll take 0. And this region I'll take 2.75. Well, let's take 2.8. 2.8, and what else? The following region I'll take one way to do it. Why am I taking 2.8? I think let me take the middle value here. Okay, I'll look at this later. Yeah, but 2.8 is fine. Let me rewrite this as 11 over 4. This is 3. Okay, 3. I'll take 4 there, that region. I want to take the middle value in this case. I just want to do that. There's no reason for why I'm doing it. So what I'll do is I'll add 2.75 to 3 and then divide it by 2. That will give me the average. Plus 3, then everything divided by 2. Okay, 4 is the lowest common factor. 11 by 1 is 11, plus 3 by 4, that is 12. 3 multiplied by 4, that's 12. So 11 plus 11, that is 22 plus 1, 23 over 4. Okay. (23 over 4). Makes sense. So I'll take that. (23 over 4). And we have 4 there. So let's test. Let's test if the condition is met, shall we? 4x minus 11. 4x minus 11 over x minus 3 should be less than or equals to 0. No, it should be greater than 0. Sorry. Should be greater than 0. Okay. So let's test out when x is equals to 0 in the first region. That means 0 minus 11 over 0 minus 3. It's positive 11 over 3, which is greater than 0. Over 3, which is greater than 0. So condition is met in the first region. Second region of 23 over 4. X is equals to 23 over 4. I have 4 multiplied by 23 over 4 minus 11 divided by x. What am I doing? Sorry. Divided by 23 over 4 minus 3. This all should be greater than and equals to 0. 4 cancels out, so we have 23 minus 11 divided by 23 over 4 minus 3. Lowest denominator will be 4, lowest common multiple will be 4, and we'll have 23 minus 3 times 4, that is 12, greater than 0. So 23 minus 11 gives us 12. 12 divided by 23 minus 12, 11 over 4. Okay, so this becomes 12 multiplied by 4 over 11, which is greater than equals to 0. This is definitely greater than 0. So 12 times 4, now you have 12, 12, 12, 12. 12 plus 12, 24. 12 plus 12, 24. 24 plus 24, 4 plus 4, that is 8. 2 plus 2, that is 48. So you have 48 all over 11, which is greater than 0. Condition is met, and I'm happy. Nice. Oops, sorry. What about when x is equals to 4? Is the condition met? Well, let's test it out. 4 multiplied by 4 minus 11 divided by 4 minus 3 must be greater than or equals to 0. 4 by 4, that is 16, minus 11 divided by 4 minus 3, that is 1 must be greater than or equals to 0. 16 minus 11, what does that give me? Well, that's the same thing as 6 minus 1 gives me 5. Just do it here. 16 minus 11, 6 minus 1, that is 5. 1 minus 1. So answer is 5. Five over 1. So all origins satisfy the condition. Well, this is a nice one, isn't it? Interesting. So all regions satisfy this condition. So our domain will be from minus infinity to 11 over 4. 11 over 4. Where's this? 11 over 4 is included. 11 over 4 is included, so this will be square bracket union union 11 over 4 11 over 4 to 3 3 which is not included, and another union from 3 to infinity. So let's plot this. 11 over 4 goes all the way to infinity. Well, and then from 11 over 4 goes all the way to 3, which is not included. Then from 3 goes all the way to infinity. One way to plot it. Another way would just say, okay, that's included. That's not included. And we're done.